Our next speaker has over 30 years of research and teaching experience in different countries. Her current research fields include AI, robotics, software engineering methods and techniques, and computer science education. Her most recent work focuses on intelligence research, particularly on defining and understanding both machine intelligence and its boundaries. Please welcome Professor Dagmar Monett Diaz, AI software engineering at HWR in Berlin, with a presentation entitled "We Want to do AI, but we don't know where to start. Yet another recipe for doing it well." This sounds super interesting. Welcome to the stage, Dagmar, and over to you.
Thank you very much. I will share in my slides in a minute. Okay. Okay, I hope you can see my slides. And yes, so the motivation was, I have been asked before a few times already, what should I do if I want to start doing some AI? Some of the people because they have genuine interest in learning and doing something with AI, but other people because AI is in the news and in everybody's mouth, and they just want to do something with that, but don't know how to do that. And I collected some instructions, like a recipe, so a set of instructions to prepare a dish. And I collected that for doing AI from the beginning and doing that well. The first instruction is start strong. So you should know, and not only for people that want to start with AI, but also for all the colleagues and practitioners with already experience in this field, I will repeat the same, know how to define AI, or at least know about definitions of AI. Or another question, how would you define AI? I know that there is no consensus on defining this field as a concept, as a field. There is no consensus on the community. The research started in the 50s, more than 60 years ago, and this was stimulated by the invention of modern computers. So in the words of Minsky, some years later, he was talking about, well, the idea was to do with machines what was actually not previously possible, in, for example, thinking like humans, acting like humans, etc. And one of his definitions, or one of the ways he defined AI, was the ability to solve hard problems. But it comes a different question now: how do you define a hard problem, or when a problem is hard? So this also poses a lot of different questions in this regard. He also wrote that instead of defining what AI is as a concept, the best thing to do, or a better thing to do, is define how we can use artificial intelligence, or intelligence in machines, or machine intelligence if you prefer. However, this is not the only definition. So if you want to deal with defining AI, if you want to know what AI is, then you should refer to other definitions too. For example, the one from Winston, very well known in the literature, very cited. It is as a field, define it as a field. It is a study of the computations that make it possible to perceive, reason, and act in machines. And also the definition from page 1, the essence of intelligence. So now, what does it mean to be intelligent is adapting to the environment. For example, when machines have insufficient knowledge and resources. This was the most accepted definition of AI in a survey that we did with my colleagues. And other very, very well-known definition is the one from Leck and Hutter. So intelligence measures an agent's ability to achieve goals in a range of environments. So achieving goals is about in a range, a diversity of environments. So not only in one domain, but also in other domains. And I tell you, and this is what I put it on the right at the top, So in our survey, but also in the literature, you find more than 500 definitions of AI, which is crazy. And you should know there is no consensus. So when you define something, when you discuss one definition with the experts, with the people in AI, with the people also outside the community, you will see that there is no consensus. Some people try to redefine, because AI is a moving target. So it depends on the application. Sometimes it is very contextual. It depends on the context, on the application you are doing. And this is why there is no consensus now, which in other fields, it has been possible. It is not possible in AI still to have a definition that defines the field or intelligence as a concept, or machine intelligence. The next instruction is, well, I want you to know, I want you to learn that AI is not only machine learning. So AI is much more than machine learning. Machine learning is one of the subfields of AI. And similarly, deep learning is one example of deep neural networks, and neural networks is one of the algorithms, one of the approaches used in machine learning. So there is much more to AI, there is much more to machine learning that only machine learning in the case of deep learning, and in the case of artificial intelligence. There is a broad variety of, since the beginning of the field in the 50s, of different methods trying to perform activities, or trying to perform tasks, trying to have, or to build intelligence in machines, or doing something intelligently, independently, autonomously, without a human supervision, for example. The next instruction from me, it is not a magic bullet. So we have a huge momentum now of AI, which is very, very good. It advances the field in a lot of different ways. But there are also some problems. I will come to that later. But I wanted you to show why this momentum is exactly now in the last few years. And one of the reasons is the big data. So we have a lot of data that algorithms can train with, and or tested also. And this is, for example, think about how much information is published on the web in 1 minute, in 1 second worldwide, in posts, tweets, videos, pictures, comments, etc. And this amount of data, huge amount of data, it has made possible to work with this information and to test algorithms, to train algorithms. It was not possible before. To train algorithms that are not new, so maybe some improvements are new, but we have now algorithms that are decades old. And these algorithms that are decades old now, and the models and the parameters, etc., are improved. Why? Very easily, or very fast, or faster compared to years before, because then we have also computer power. We have powerful GPUs, for example, just designed in order to deal with AI, but also very powerful hardware now we can use, and then have results faster. We can train again the algorithms, tune the parameters, and so on. But we have also other reasons, for example, cloud computing. We have platforms for development and storage of information and algorithms, etc. For example, like TensorFlow for dealing with machine learning algorithms as well, that we didn't have before, also in a collaborative way. And we have, add to that, we have open access and open source. So we can improve, we can have the code, not always, I have to mention that, but we have a lot of different experiments, different source codes, for example, published in GitHub, with practitioners and new people enter into the field, but also others can also use, download, and adapt to a new problem. And open access, because now we have publications. We don't have to wait until a conference publishes the proceedings, but we also have proceedings, or people that upload, for example, to archive. They are papers, they are scientific work or publications before they send that to the proceedings. And we can read that and we can have the latest information before the conference or the workshop or the events or the book gets published. And this all I have contributed to the AI momentum we have, because this allows the applications to very, very different kind of problems that have been solved in the last years using these methods. The next instruction, and it is very important, AI in the lab with toy problems is not the same as AI in the world, dealing with real problems. I only want to cite one example among thousands of examples. One example why it is important. So imagine you have an AI algorithm, machine learning algorithm, dealing with the neural networks, very, very fast and very, so from the research point of view, from the theoretical point of view, with the highest accuracy that you can get, take 99.99%. Well, there will be 0.001% that it is maybe wrong predicted. And imagine it's a woman that have to undergo chemotherapy. What that can means maybe for her and her family financial situation, it could go bankrupt in some countries. Maybe she can go emotionally, but also the chemo. What will be the implications? And because it is wrong or it is a false positive, wrong predicted by the algorithm. So you are not dealing with the next move in a Go game or in chess game or in a toy problem. You are dealing with people, with human beings. So be very careful. You are very, very powerful algorithms in the lab doesn't mean that they are also very powerful in the real world or that they can be applied in all different scenarios you can have. The next one, well, some words on artificial general intelligence. It is not linear. So some people tell you in 5 years we will have machines that will overgrow or something like that. The humans, more intelligent than humans, doing everything that humans can do. Well, I belong to the ones that think that it is far, far away. We are not so far at this moment. I would suggest you, I would recommend you to read the book from Melanie Mitchell, a very well-known renowned expert around the world, AI expert. And she says, okay, if you rely on movies and science fiction in order to have your view on AI, of course, you will be afraid of AI becoming conscious, turning malevolent, and trying to enslave or kill all of us. But given the state of the art in AI now, we are far from achieving this general intelligence. It's not near. I will mention also the book from Woolbridge. So also a very renowned scientist, AI scientist worldwide. A great book together with Melanie books. For the general public, these are not technical books, theoretical books on AI, but for the general public, I would recommend you to buy those books. And he says the same. So the long dream of AI from the beginning was to have to build machines that are self-aware, conscious, autonomous in the same way you and I are. However, the reality now, the algorithms we have, very narrow in very narrow scenarios, very, very powerful, okay, but not these capabilities of intelligent actions you could think AI have. We are not so far. The next recommendation or the next instruction from my recipe, do not feed the AI hype. You know from the news there is a lot going on from apocalyptic scenarios and situations that where the people get afraid for no reason. So AI, I say it is irresponsible journalism because it misinforms the general public. And the people have some idea about what AI is that it is not. I will mention one recent study from Bitkom Research 2020, a survey done in Germany. So estimated by the general public, 77% of companies personalizing advertisement. In reality, what the companies were actually doing was only 4%. A different one, automatic answering to customer questions. 55% of the people thought, yes, this is done, and it was only 3%. So the reality and what the people think AI can do is very, very, very different. I will mention now a recipe, but in the other way, a bad recipe. Don't do that. And this comes from the book from Melanie Mitchell. So some people also inside the community take a very, very narrow, useful task and then collect a large set of data for testing machine performance on that task, then perform a limited measure of human ability on that data set, and then put to compete in a competition what humans do, or how do humans solve the task and how the machine solve the task, until the machine wins, and then report the, of course, maybe impressive and useful results, but also claim falsely that this AI, this winning AI, can solve also other tasks in a more general scenario, which is not. And this, of course, fit the hype. We are doing things that are great, and also in this and that scenario. Then you have that in the news, there is an AI that can understand human language, and no, we have no understanding of human language yet. We have a lot of improvement. This is great. And I am so happy. Had I had that at the beginning of my career in AI 30 years ago, I would be maybe still here choosing this field. But it is not the case. It is not the case. There is no understanding yet. And what you have is some companies that advertise, that say, this is what we have, this is the AI we have. But at the end, they have nothing inside, or almost no AI. Only part of the things is AI. And let's not talk about explaining AI, how the algorithms work, or how this black box work, and how the marketing, of course, says how much AI is inside. These problems, they should stop. So my recommendation, don't feed the hype. Be responsible in this way. Be transparent too, be ethical, not only when using AI, but also when designing from the beginning, when developing the systems, when deploying those systems, and also as a user, be responsible. Be responsible if you want to buy some algorithm that has AI inside to solve some problems. So not only as user, but also as companies buying these AI products that maybe you can use inside your company. And then I will point you to the work for, among many, to the work from Taylor and colleagues, which had made a great survey asking which are the most important areas around and issues around responsible AI. And there you have ethical AI, transparency, design, responsibility, socioeconomic impact of these algorithms that are being developed. So you can find more on the link that is provided, and I suggest and recommend you to go for more, not only testing very powerful algorithms, but also what is behind, analyzing the implications behind. So the last instruction from my recipe, be informed. So you can also learn a lot about AI, what others are doing in AI, and be humble. Be humble and tell the truth about what the algorithms you are developing. Now, hopefully, you develop more algorithms to solve the most pressing problems we have as in our world. Thank you.